Yes, so I'm going to talk about potential controls on trends in background concentrations of mercury in the northeast US. So the data I used for this study were from these three sites. Well, the study, I started doing analysis with measurements from Monadnock and Thompson Farm originally. And then after the analysis was presented last year, then someone suggested I should use some more sites, which made perfect sense to me. So I went back and I tried to get data from Huntington Wildlife Forest. And I meant to use data from the site in Vermont as well, upon Tom Hosen's suggestion. But then I'm still waiting for the data until last week. Charlie suggested I should just talk to Dave about it. So I was kind of slow about the source of data. But in any event, let me introduce these three sites briefly. Thompson Farm is a coastal site. It's at sea level. And Monadnock was 700 meters above sea level elevation, about probably 100 miles from the coast, from the ocean. And Huntington Wildlife Forest, it's in the Adirondacks, and the elevation is 510 meters. And Zhao Yan did a couple of studies using measurements from that site, right? So I was focusing on the background concentrations of GEM. So how did I do that? I just picked out, this is 5-minute data. So I picked out all the all the data points corresponding to CO levels less than 25th percentile for each month. Average annual cycles were removed from it, from the time series. So I calculated the monthly median values from all the data points I subtracted using this criteria, at least for Monadnock and Thompson Farm. Now, so these values, I call them monthly median anomalies. So-called anomalies is simply because the annual cycle was removed, okay? But for Huntington Wildlife, I did not have access to CO data. So what I used was the lower 25th monthly lower 25th percentile values of GEM for Huntington Wildlife. All right. So this is what we had for Monadnock. That's the mountain side. We had data starting from late 2005, November 2005 probably. And then it goes all the way to 2010, August 2010. So with the annual cycle removed, this is a monthly median anomalies. And you see a very distinct declining trend. And the rate of this declining trend is, the rate of this decrease is 3.8 plus minus 0.9 ppqv per year. So this is very close to what Meshead got, which is about 3 plus 1.1 ppqv per year from Ebbinghaus's data. And it was also very close to what Slammer et al. Got from Cape Point. And then I also looked at a whole bunch of sites from Canada in mid-latitudes and subarctic region, and they had also a range that encompasses what we have here. So it really makes sense because our site is on the west side of the North Atlantic Ocean, and then Meshead is on the east side of the Atlantic Ocean, and they were pretty much near the same. They're at very similar latitudes. And so were these sites. So these are on the North American continent. Now, however, when I was looking at the sea level site, there's a coastal sea level site, I did not see any trend. Then I went to look at a Huntington site, and there is some sort of trend. Well, there was very high values in the first two years. Then it would kind of decrease a little bit. So overall, there is a trend. So I must point out this declining trend for Pac-Monadnock was statistically significant, whereas these two are not. So you might be thinking, the data I had different data records, or different lengths for these data records. So for the overlapping period, which is February 2006 to August 2010, I did these trends again, and it turned out still for Pac-Monadnock, there's a pretty significant declining trend, which is very close to what we got early on. And then Thompson Farm and Huntington Wildlife, those two trends are still insignificant. So I was thinking, are those trends very similar or different for each month? Because there are different sources and sinks and processes for different months of the year. So I looked at a Pac-Monadnock, and these significant declining trends occurred in May to June and in October to November. And the largest one occurred in November. And for Huntington Wildlife, it was kind of a mixed picture. So the significant declining trends were found in January and July, whereas in spring, in April, there was a pretty significant increasing trend. So that was interesting. So it kind of, all these trends, they kind of cancel each other out. So in the end, on an annual basis, we saw very insignificant trends. For Thompson Farm, that's very interesting. So for all these months, you saw the 2 months in the fall and a couple months in the spring. The declining trends were insignificant. And in the summer, there was a very significant increase in trends. So apparently, well, I guess not apparently. So my guess was it seems like a different processes, obviously, are controlling these trends for different seasons at different sites. And bear in mind, the Pac-Monadnock is a site at 700 meters above sea level. So half of the time, I would say, it was less impacted by surface processes. It was exposed to, probably it's got more chance to be exposed to free tropospheric air compared to the other two sites. Now, Huntington Wildlife kind of surprised me because it's got a 500 meters elevation. So you would think it's probably at the top of nocturnal boundary layer and might not be that affected by surface processes either. But it turns out it's different. When you look at their time series of GEM, we actually saw quite a few nights with GEM depletion. So that's an indication of a lot of times Huntington was actually within the nocturnal boundary layer. So then I was thinking, what kind of temporal variations you might see from, let's say, the air masses highly influenced by anthropogenic emissions from those three sites. So what I did is I picked out all these mercury concentrations corresponding to the monthly 75th percentile CO mixing ratios for Thompson Farm and Pac-Monadnock. So again, so we start to see statistically significant declining trend at Thompson Farm. And then very significant declining trend at Pac-Monadnock, and also a better defined declining trend at Huntington Wildlife. Well, for this site, I said we had no access to the CO data, so I used the monthly 95th percentile HG0. All right, so again, I was thinking, so you look at these numbers, actually, I would say they are comparable. I mean, they are different, but they are actually comparable. So now I was thinking, like, what the monthly variations would look like in those highly anthropogenically influenced air masses. So it turned out for Pac-Monadnock, throughout the year, most of the months you see pretty significant declining trends, right? Well, these are the statistically significant trends, mostly in the summer and in the fall. Whereas Huntington wildlife is mostly in the spring. And for Thompson Farm, it's in summer and in winter. And it actually makes sense for this. It's because in the colder months, the anthropogenic influence would be more dominant, whereas in warmer seasons, there will be other natural processes become important. And this from Thompson Farm particularly shows that in the summertime. So I had a point here. It's for Thompson Farm, other sources of processes in warmer months could overtake anthropogenic influence. All right, so I want you to go back to this slide again to look at this HG, the time series for the HG MMAs corresponding to the 75th percentile CO mixing ratios at these sites. And you would see it seems like it started to decrease from the beginning, right? And then in the fall of 2006, there is a jump. And this same thing also occurred at exact the same time for Pac-Monadnock. However, for Huntington wildlife, it came in like 3 to 4 months late. And if you look at the background concentrations, it showed the same abrupt increases in the fall of 2006 for Pac and for Thompson Farm as well. Although this increase in the fall 2006 did not affect overall trends at Pac-Monadnock. And for Huntington wildlife, you also saw that. So I thought you could actually subtract the background concentrations from the anthropogenically influenced concentrations. The difference should reflect the trends of anthropogenic contribution. Again, this is not, bear in mind, this is not point-to-point calculation. This is the first order of magnitude estimates. So it just gives you a rough idea. So this is what I did. I subtracted the background concentrations from the 95th percentile ones. And then you see all these trends, very significant declining trends. This reflects the changes over the years in terms of anthropogenic contributions. And for Huntington wildlife, the number was enormous. That's simply, I think, in large part because it was driven by the really large number during the first couple of months. And my guess is it's a lot of local emissions maybe at the time. It was only the first couple of months though. Yes, no, well, yeah, summertime. But we can talk about this later. Let me just go through this. So then at that point, I was thinking, why Thompson Farm seems to be particularly impacted by this feature, this increase in the fall of 2006, whereas Pac-Monadnock wasn't so much so. And my hypothesis was it must be associated with the surface processes, the processes within the planetary boundary layers. Because you imagine if this site, half of the time, was above the planetary boundary layer, then it should be less impacted by what's going on near the surface. So I checked just about everything, like temperature, soil radiation, clouds, and circulation patterns, and precipitation. It turns out only precipitation, the combination of precipitation for the fall of 2006 and the winter 2007 seems to be very unique compared to other seasons. If you notice in the fall, there was the largest amount of precipitation, and in wintertime 2007, it was fairly dry, and I'm going to show you later on next slide. And so then I went to Huntington Wildlife, look at it as well, but it wasn't as obvious, a combination as what I saw at Thompson Farm. However, you still saw abundant precipitation in the warmer months, and whereas a fairly dry winter season. So this is, we also did a 3 years wet deposition, mercury wet deposition sampling at Thompson Farm. So this is a fall 2006, and this is a winter 2007. And if you compare this with the other 3 years, you can see the precipitation amount was the largest in fall 2006, and the winter was the lowest, if you compare them. So here's my hypothesis. I was thinking, during fall, it was also a season where there's a foliage, and all this mercury goes into the ecosystem. And if there is a lot of precipitation, then that really helps this deposition of mercury into the ecosystem. And then in the wintertime, if there's less snow on the ground, it might impact, it might impact the surface evasion, the evasion or mercury evasion from the ecosystem. So which means if there's no buffer layer near the surface, there might be more mercury that will be emitted from the ecosystem into the atmosphere. So that's why throughout the entire 2007, the year of 2007, you saw unusually high concentrations of Hg0. So I was hoping to find this for all the sites in the northeastern US. That would make more sense, because to impact the concentrations of background concentration, to impact the background concentrations, the processes have to be regional. Anyway, so this work is still in process. I've been waiting for soil data from some colleagues, but it's been very difficult. So if you have any input, or if you have data from me, that would be really extremely welcome. I think I'm just going to stop here.
Any questions?
Oh, yeah.
Just a quick comment.
Okay.
I think it's a very good study, and everything you said makes sense to me. Just want to add that for the sea level site,
Yeah.
you don't see any trend, don't see any decrease.
From the ocean?
Yeah, you don't see any decreasing trend for background information.
That's right,
level.
that's right, yeah.
That actually supports, can we safely say that's because that site is mostly affected by ocean?
No, well, I forgot to mention, in the paper I'm writing now, I had that part. When I subtract the data, I eliminate the oceanic inference. So I just had the winds coming from inland. I had no I tried to eliminate all the oceanic inference, but I'm not sure if that would be very complete.
Okay.
Okay.
Thank you.
Thank you. So there's been a change of speakers for the Institute of Atmospheric Pollution.